Let us solve the equation x to the power 6 equal to x minus 6 to the power 6. Now you see that left hand side is a polynomial of degree 6, right hand side is also a polynomial of degree 6. So we write the equation x to the power 6 equal to x minus 6 to the power 6. Now you see that let's take this quantity x minus 6 to the power 6 to the left hand side, because we prefer to use equal to 0. We mostly search for equal to 0 or equal to 1. If I write x minus 6 to the power 6 to the left hand side, then we'll get x to the power 6 minus x minus 6 to the power 6 equal to 0. That can be written as x cube whole thing square minus x minus 6 cube whole thing square equal to 0. So something square minus something square equal to 0. That reminds us of the formula a square minus b square. That's equal to a plus b into a minus b. Let's apply that. A plus b, a equal to x cube. So x cube plus x minus 6 cube, b equal to x minus 6 cube, a plus b into a minus b, x cube minus x minus 6 whole thing cube equal to 0, copy as it is. Now you see that product of two number equal to 0. If both of them are not equal to 0, then it will never happen that their product is 0. So one of them has to be 0. Maybe x cube plus x minus 6 to the power 6 equal to 0. Maybe this one is equal to 0. Or maybe x cube minus x minus 6 whole thing cube equal to 0. At least one of them equal to 0. Or maybe that both of them are equal to 0. We don't know exactly which one is true, but at least I know that at least one of them has to be equal to 0. Let's look at the case 1. So we consider the case x cube plus x minus 6 to the power, so x minus 6 to the power 3 equal to 0. X cube plus x minus 6 cube equal to 0. Now we can expand it. X cube we copy as it is. Instead of expanding, let's use the formula a cube plus b cube. It can simply be factorized into a plus b into a square minus ab plus b square. So we can write above expression as a plus b, x plus 6, a plus x minus 6 into a square minus ab, x into x minus 6 plus b square plus x minus 6 whole thing square equal to 0, copy as it is. Now we see that x plus x minus 6, that is 2x minus 6 into x square minus x square, x into x is x square, minus x into minus 6 is plus 6x. What about this one? A minus b whole thing square, that's equal to a square, so x square, minus 2 into a into b plus b square equal to 0, we copy as it is. Now once again we are having product of two number equal to 0. So we must have that either 2x minus 6 equal to 0. If you look at this expression, you can cancel x square out, and then x square we copy as it is, minus 12 number of x and plus 6 number of x, so minus 6 number of x plus 36 equal to 0. If 2x minus 6 equal to 0, then 2x equal to 6. That gives us x equal to 6 by 2, and that's equal to 3. Well, pretty simple. What about this one? This is a quadratic equation, ax square plus bx plus c equal to 0. Roots are given by x equal to minus b plus minus root over b square minus 4ac divided by 2a minus b. So here b equal to minus 6. So minus of minus 6 is plus 6. plus minus root over minus 6 whole thing square minus 4 into a equal to 1, c equal to 36, divided by 2 into a is equal to 1. 6 plus minus root over 36 minus 4 into 6 is 24, 4 into 3 is 12, 12 plus 4 is 144 divided by 2. 36 minus 144 is minus 108. You see that square root of negative quantity is not a real number, so this equation is having no real solution. But if we look at the complex number, then we can write this as 108, that's 36 into 3. Square root of 36 is just 6. Square root of 3 as it is, and square root of minus 1 is I divided by 2. That's equal to 3 plus minus 3 root 3i. So we are done with this case. So in the first case, we observe that we got x equal to 3, a real number, and x equal to 3 plus minus 3 root 3i. That's a complex number. So we got 3 roots. What about the second case, x cube minus x minus 6 whole thing cube equal to 0? Once again, we apply the formula a cube minus b cube minus b cube equal to a minus b. It can be simply factorized. A cube minus b cube can be factorized into a minus b into a square plus ab plus b square. Okay, so a minus b, so x minus 6 into a square, x square, plus a into b, x into x minus 6, plus b square, x minus 6 whole thing square. So here also we got product of two number equal to 0. Then one of them has to be equal to 0. Now x gets cancelled. Minus of minus 6 is plus 6. That cannot be 0. What about this expression? X square plus x square minus 6x. What about x minus 6 whole thing square? That's a minus b whole thing square. That's equal to a square minus 2ab plus b square equal to 0. Copy as it is. Now 6 cannot be equal to 0. So this quantity must be equal to 0. One number of x square, one number of x square, and one number of x square. In total, 3 number of x square. Minus 6 number of x and minus 12 number of x. So in total, minus 18 number of x. Plus 36 equal to 0. Oh, you can see that you can take 3 common. Let's take it. X square minus 6x plus 12 equal to 0. Once again, that's a quadratic equation. Ax square, 3 cannot be equal to 0. So ax square plus bx plus c equal to 0. Roots of a quadratic equation is given by x equal to minus b plus minus root over b square minus 4ac divided by 2a. b equal to minus 6, so minus of minus 6 plus minus root over b square, so minus 6 whole thing square minus 4 into a equal to 1, c equal to 12 divided by 2a equal to 1. Minus of minus 6 is plus 6 plus minus root over 36 minus 12 into 4 is 48 divided by 2. 36 minus 48 is minus 12. So once again, we are not getting real root. So this is minus 12 by 2. So that's equal to minus 12 is root over 4 into root over minus 3. And that's 2 into root 3 into I. So we can write this as 3 plus minus 2 root 3i by 2. 2 gets cancelled, so we get 3 plus minus root 3i. So we see that we are getting 5 number of solutions. X equal to 3, that's the real solution. X equal to 3, that's the real solution that we have obtained. And then 2 number of complex solution in the first case. 3 plus minus 3 into root 3i. x equal to 3, that's a real number, and x equal to 3 plus minus 3 into root 3i, those are the two complex number, and then lastly 3 plus minus root 3i. So in total 2, 4, 5 number of complex solution, but only one real solution.